Yeah, so the first visual illusion we're going to talk about is called Miller's illusion. In this Miller's illusion, these two lines are of the same size, yet our brain perceives these two lines of different size, and it appears like this one is larger than this one. Now, um, we'll come back to this a discussion on why our brain interprets this as larger than this. But let's look at another example where the Miller's illusion is at work. Now, this and this are the same size, but this is looking larger than this. And and before we talk about why it is so, let's look at an explanation as to, in terms of two different things. Number one, if you remember the discussion on the size constancy, in other words, an object size stays constant irrespective of whether it's closer to you or away from you. So if you see something increasing in size, you assume that it's getting closer to you. You don't assume that smaller things are becoming bigger. We assume that things don't change their size. Size remains constant. Now, the image of this line and this line that's formed on our retina is of the same size, but brain interprets it differently. Now, why? We can understand this. There are several explanations, but one explanation is this. We can combine our understanding of the size constancy and distant perception together to kind of interpret how our brain gives us this illusion. Now, although these two are of the same size, the fact that it has an inward wing gives us an appearance that this is closer to us. It's as if the outer corner of a room. Whereas because of these outward wings, right, this looks like an inner corner of a room. Now, an outer corner of a room and an inner corner of a room gives us different perceptions about how far this line is from us. An outward corner of a room looks closer or appears closer to us, and an inward corner of a room appears away from us. Now, so you can explain this in terms of like, okay, the size of these two lines is same on the retina, yet one appears closer and the other appears away. And we know that when objects go away, they decrease in size, yet our retina is actually seeing these two as the same size. The only explanation then would be to imagine the brain interprets that because it is looking because the size of this is same as this one, even though if it's farther away, our brain assumes that it's probably larger than this one. So that's Miller's illusion. Again, there is no perfect explanation for this. This is one potential explanation that I found more reasonable. Now let's get to the second illusion called the Ponzo illusion. In this illusion, although these two lines are of the same size, let me show you. But it appears that this as longer than this one. And again, you can understand this by taking into two different key assumptions here. Number one, our brain believes that parallel lines, right? Parallel lines, they come closer when they are farther away from us, and parallel lines look more away from us when they're closer to us, right? Now, assuming that maybe it is that the image of this and this line is same, the image of this formed on retina is same. So our brain kind of interprets as, wait a second, these two lines are the same size, but according to the linear perspective, this line appears to be farther away from us when compared to this. And when an object is farther away from us, its size decreases. But given the fact that it is of the same size, but it's farther away, it suggests that this is larger than this one. So that is one explanation for Hanzo's illusion. Now let's move on to the other illusion called the impossible figure. Now here our brain tries to interpret this as a whole object while it actually is not. So if you individually look at the parts, like these three look as three different prongs, and if you look at this part, it looks like it's I don't know, it's like a U-shaped structure. So our brain tries to capture the entire image as a whole, which may make sense at individual points, but altogether you can't imagine it. That's why it's impossible figure. Now, going to the next illusion, the moon illusion. Now, if you look at a moon, if you look at full moon, look at the full moon when it's up in the sky, and compared to the size of the moon when it is at the horizon like this, it appears like this is bigger if it is on at the horizon as opposed to when it is in the open sky. In actuality, though, the actual size of the image that's formed on a retina is same irrespective of whether it is at the horizon or it's up in the sky, open sky. Now, there are several explanations for this. One explanation is called the relative size hypothesis, and according to this hypothesis, the moon has other structures when it's at the horizon to compare it to, and it looks bigger because the objects that are away are supposed to be smaller, and when compared to the objects that are closer here, still it is looking bigger, as giving us an illusion that it is larger. But the same moon, when it's in the open sky, there are no other objects to compare it to, and it appears smaller. So that is the moon. So the next illusion we're going to talk about is called the stroboscopic illusion. Now you may have noticed this is an illusion where you feel like there is a movement, and actually there isn't one. It's the illusion of an apparent motion. Now, to explain this, a better example would be a flip book. Now, when you look at this flip book, there is no actual motion of the object, but each image is slightly different from the previous one, and it is presented at a specific rate. It's around 20 pictures per second, and because it is presented so quickly and there is slight difference between any two given images, and it gives a feeling of apparent motion. Actually, there isn't one. And that's the same reason behind the motion picture. When you watch a movie, it's not because there is actually some motion in there, but it's because of it's a series of pictures shown with slight changes, and it is presented with a specific speed, so our brain interprets these changes as actual movement or actual motion. So, so a movie, when you watch, it's basically a set of slides of pictures, and our mind creates a notion of motion in there. Okay, let's move to the next topic, the controversial topics in perception. Now, this we're going to first talk about subliminal perception. Subliminal perception is when when the information is presented to you either through visual, auditory, or any other means, but it's not consciously available to you. And the question is, does that less than conscious level of presentation of information through our senses, does it affect or influence our attitudes or behaviors? Now, I'm going to talk about one specific study where the participants were subliminally shown either images of an Apple logo or an IBM logo. Now, what it means by showing subliminally is presenting these images to a person, but at a rate so fast that the individual doesn't remember or consciously aware of this information being presented to them. And later, when the same participants were shown or given a task called the creativity task, it was shown what researchers found was the participants or the group that saw the Apple image did more creative, did well on the creative task when compared to the IBM, suggesting that this subliminal below level of conscious processing of these pictures had somehow influence their ability to act creatively in a given scenario. Now, there is no real evidence other than some experimental or contextualized control conditions. There is no real evidence to suggest that it really works in the real world. Um, again, we don't have enough evidence to think so. Now, there is another controversial topic that is, I think, is more interesting, and that is ESP. ESP. It's the extrasensory perception. It is our perceptions beyond the five senses we have. So that's why I have this picture of the sixth sense. We're talking about sixth sense here. The different kinds of ESPs, and usually there is a field psychology called parapsychology that examines these phenomena specific to extrasensory perception. And basically what it means is our perceptions of things beyond utilizing our five senses. Now, there are several kinds or examples of this. One is clairvoyance. Clairvoyance is basically a person claims that he knows or she knows about the events that are happening at the same time but elsewhere. Or precognition, for example, is an individual believes that he can foresee the future. Or let's take the telepathy. Telepathy is when the individual thinks that he can read the minds of others. There is another uh, called psychokinesis, and sometimes it's actually called telekinesis. It is it's not just extrasensory perception, is beyond that. It is the idea that people can actually control the objects in the real world. Like you may have seen this person who claimed that he can actually bend the spoon without actually bending it with his hands, which again is not ESP, but still it's about having this extraordinary abilities beyond the normal. So, well, the research on ESP is little to none. Critics say it is not science. There is no real evidence to suggest it, and I haven't seen any either. But that's about controversial topics, and that's the end of this video on perception.